Hello, and thank you for attending this webinar. Today we will be discussing Intelligent Customer Engagement with Microsoft, Disruption in Manufacturing Industry, Microsoft Dynamics and Mixed Mode Manufacturing, our customers and analyst reviews, and we'll also have a summary with conclusions. With that, I'm handing it over to Bill Moffitt.
Thank you very much, everyone, for your time today. I'm Bill Moffitt, and I'm a Global Industry Product Marketing Manager, specifically focused on the manufacturing industry. My responsibilities at Microsoft include helping drive Microsoft's vision and strategy for the manufacturing industry. This includes the strategy and vision for not only Dynamics AX and CRM, but also how we leverage the entire Microsoft product portfolio to address the needs of manufacturers. Today, I'm going to talk about Microsoft's vision of how manufacturers can effectively engage with customers and business partners. This is what we call a dynamic manufacturer. Let's look at the characteristics of a dynamic manufacturer. First off, a dynamic manufacturer is innovative. There's a focus on continued innovation throughout the organization. It is instilled in each and every employee to continually improve. This organization is one that requires connectivity, not only to internally, but also with the valued suppliers and its customers. This manufacturer is highly adaptive and effectively handles a continually changing business environment. Whether it's the competition bringing new products to market at lower prices, changes in the supplier ecosystem, or even governmental regulatory changes, this manufacturer is agile and responsive. And finally, the dynamic manufacturer's most important resource is its employees. These employees are able to use tool sets that are specifically built for them with their needs in mind. These tools provide accurate information in a format that is easily digested, which allows them to make critical operational decisions quickly and effectively. These employees are truly engaged in the business. Now let's look at operations, the traditional centerpiece to an effective manufacturer. A typical manufacturing organization uses many different software products that are designed to address various operational requirements. Manufacturers have systems for CAD designing, product lifecycle management, warehousing control, manufacturing execution, and the traditional ERP systems. Unfortunately, many of these solutions are designed to work in a vacuum, in a way that fosters silos of information within the organizations that use them. At Microsoft, we fully believe that to build a true solution, you need to have the right platform that can scale, advance with technology, and adapt to changing business needs. It also needs to have an interface that users are familiar and comfortable with that works the way you do. And finally, the solution needs to bring resources together within your organization. It should foster a behavior of collaboration and help drive a culture where people work together. Traditionally, for manufacturers, the focus was always on simply driving efficiency and effectiveness with operations. The basic idea was simply that the only lever that could be pulled to determine how effective a manufacturer can be was how low you could get production costs. In reality, though, manufacturers have found a tremendous amount of success by engaging directly with their customers. This means that their effectiveness and profitability is now more directly impacted by how well their sales, marketing, and service organizations are. With technology improvements such as the Internet of Things, manufacturers now have the opportunity to connect people, processes, and assets, and better harness data from across your business and operations. For example, you can see that we have a typical vending machine. However, when the vending machine is connected using a sensor, it can suddenly give off a pool of rich, useful, and insightful data that can be housed into the cloud and used in a variety of different ways. That data can be consumed by local field technicians or customer service reps in real time, to headquarters where it can be used by planners or even control center, which can monitor the overall health and usage of the vending machines. Through this continuous connectivity, updates to the machine systems can be sent directly to the field service rep to make repairs before the unit breaks down. And this isn't just happening on one vending machine. If you're managing units across the world, this can be seen at a global view. Imagine seeing what thousands or even millions of vending machines are doing in real time. Within the manufacturing industry, organizations face a number of challenges, including limited awareness of customer service issues, disconnected internal departments, and insufficient tools for optimizing the customer experience in a competitive marketplace. Dynamic CRM and leveraging the Internet of Things, or IoT, manufacturers can enable their sales, marketing, and service departments to collaborate effectively and positively impact business. In this environment, manufacturers learn of customer issues before they're reported so that they can create amazing customer experiences and become more responsive to customer needs. During my demonstration in a moment, you'll see an example of a manufacturer intelligently engaging with customers using the Internet of Things. The Internet of Things provides manufacturers the opportunity to harness data from across their business and operations by connecting people, processes, and assets. The demo features a customer service rep who engages with a customer to resolve an issue, and a sales manager who gathers insights to make intelligent sales and manage marketing campaigns. In many organizations, the customer service department is more of a support entity. In today's Internet of Things digital era, however, customer service reps can use connected devices to proactively learn of issues and take immediate action. In this scenario, Jim Hance is a customer service rep at an electronics manufacturing company. He uses Dynamic CRM to detect and solve a product issue. Jim uses the customer service representative dashboard to monitor active cases and the activities associated with them. He can see his active case mix at a glance, or drill into the chart to see the underlying records. By selecting the largest wedge at the pie chart, he can see which case type is most common and drill deeper to find out why. Notice that these cases have an origin listed as device. Unlike traditional customer service requests, these particular cases were automatically created by Dynamic CRM, which detected that the smart TV application isn't loading for some customers. We received this notification from internal sensors built directly into the television sets. Knowing the origin of the problem and how the case was created helps Jim better understand his cases when resolving customer satisfaction issues. Jim drills into the record at the top of his queue, which is high priority, and can now resolve the case right from there. First, he reviews the case details, activities, customer information, and recent cases. In the research stage of the case record business process flow, he can find similar cases from across the organization to aid him as he decides the best course of action. In the perform service stage, Jim can point the customer to online support via the self-service portal, chat directly with the customer online, and more. And in the cross-sell upsell stage, he can recommend associated products such as a home theater system to the customer. Since this customer is interested, Jim indicates this in the system. Notice that the business process flow is dynamic and that a complete sales stage was automatically added so that the opportunity can be followed up with later. By proactively engaging with the customer, Jim was able to investigate the issue and even make an additional sale. Not only do we have a proactive customer service, but we now have the automated services that create cases on issues that customers are not even aware of. With Microsoft Dynamics CRM enabling IoT, we can foster amazing customer experiences and drive even closer customer relationships than ever imagined. Connecting marketing, sales, and service departments while leveraging the Internet of Things can greatly impact opportunity management as well. In this next scenario, we'll follow along with Spencer Lowe, a sales manager at the company who uses Dynamics CRM to look for sales opportunities and effectively monitor marketing campaigns and activities. Spencer begins his day reviewing the Area Manager dashboard, where he can monitor his open opportunities and where they came from. This chart at the top indicates that many of the opportunities were system generated based on past opportunities. He then reviews his top customers and sales pipeline. Next, he switches to Excel Online to see an analysis of TV sales in his region. Spencer sees a visually compelling and comprehensive view of regional TV sales data using Excel with Power BI, offered through Office 365. He can even filter on sales of a specific product for more detailed information. Spencer then plays a time-lapse view to see revenue earned per salesperson over time and notices that Mark has not brought in as much revenue as the other team members. Next, Spencer decides to review his top accounts to see how they were doing. He opens up the account record for Northwind Traders, his largest customer. Here, Spencer can stay up to date on the customer's activities, opportunities, and recent cases. He can also view insights powered by Inside View, which provides customer data from an external source. He can even call the customer using Skype right from within Dynamics CRM. Next, Spencer takes a look at an opportunity he has with this customer. Spencer sees that his opportunity was system generated, meaning it was automatically created based on an intelligent analysis of that customer's buying patterns based on previous purchases and buying history, market trends, and information from sensors indicating item usage. This intelligent analysis uses machine learning available in the Azure cloud and helps determine the customer's next buying opportunity, which is automatically created in Dynamics CRM. No longer are companies dependent solely on sales representatives being great forecasters and accurate data entry resources. With connected devices using the Internet of Things, we now have accurate forecasting based on strong analytics. Spencer knows they've had success in upselling customers on new 4K televisions, especially if the customer's existing TV is already old. Using Dynamics Marketing, Spencer is in the process of finalizing a campaign that will automatically drive new product sales as previous models come up for renewal. Here, Spencer can see an overview of the campaign, including a description and campaign objectives. In the campaign automation screen, Spencer sees a visual workflow of the campaign, including the number of customers targeted, emails and social media posts sent out, and the web traffic generated as a result. He can even target each TV specifically and notify the user when and how to upgrade to a new model. In an effort to help validate the effectiveness of their marketing campaigns, Spencer uses Microsoft Social Engagement to monitor social buzz and identify key topics his customers are currently talking about on social media. Using the tool, he can view trending topics such as 4K renewal, which was linked to his campaign with the hashtag #MoveTo4K. He is curious to see what customers are saying about the new TV and decides to investigate. Spencer sees that sentiment is mostly positive and scrolls down to see when the posts were made and where they're coming from. He can even drill down into individual posts to see exactly what people are saying about the new TV. By proactively analyzing market opportunities and reviewing marketing campaigns, Spencer is able to stay close to customers and can track his company's impact through direct customer feedback. As you've just seen, manufacturers now have the ability to get closer to customers than ever before. No longer are they limited to information provided by their distribution channel. They now have a direct one-to-one relationship with the end users of their products. They can now effectively manage marketing campaigns, monitor the true return on their investments, and even track their impact in the marketplace through sentiment and direct feedback. Not only do we have an environment where internal departments like sales, marketing, and service are connected, but we have an environment where the manufacturers are connected tightly to the marketplace, where customer views get shared, issues get resolved, and expectations get exceeded. With a connected environment leveraging the Internet of Things, we can now truly delight customers. Now, we've seen the impact on the customer and how we can directly engage with them. Now let's see how Dynamics AX can handle the demand and manage the execution piece of the pie. Let's transition over to my colleague, Gil Garcia.
Thank you, Bill. Those guys in the front office have access to some mighty fancy tools, but I have to deliver on what those customer service reps promise out to the customers. And believe me, if I don't, then I'm going to hear about it on social media and other ways that my manufacturing counterparts are going to alert me to. One of the things that we have to be able to deal with in any manufacturing environment is the ability to handle an end-to-end supply chain, front office as Bill annotated, but also back through the suppliers and production components of the supply chain. And one of the things that we are seeing more and more of is what we call a mixed mode environment. That is, enterprises that have to run their manufacturing plants in a variety of ways. You can see on the right-hand side when we talk about a manufacturing operation solutions, we're talking about really four major types of manufacturing philosophies. Lean manufacturing using Hujunka board and Kanban moves is gaining in popularity. Those companies that build large projects have a lot of bid quote process, heavy engineering, and heavy CPQ, run project-based manufacturing processes. The traditional discrete bill of material and routing that most of the manufacturing companies out there are running today, and process manufacturing, those companies that essentially use a formula and a recipe in order to make their products. What we see is mixed mode in a single plant, so you might have process and discrete manufacturing processes within the four walls of a single plant, or mixed mode manufacturing in a single enterprise, one that's vertically integrated. And that's the example we're going to look at today. We're going to look at a manufacturing plant that has both lean process and discrete process in a single enterprises. Today, unfortunately, we won't talk too much about project management, but I think 3 out of 4 is a good start to get that concept of mixed mode manufacturing across. So let's extrapolate Bill's example that he was using in the CRM example. So we're talking about a company that builds electronic components. And in this example here, we see a big screen television with some high-end speakers and a DVD or a Microsoft Xbox, if you will. And that company provides all those components either through subcontracting process or actually making the product themselves. I'm going to use one example, in this case the speaker systems. That speaker system is really made up of a variety of components. So you can see the part number on the right-hand side. Item A is part number 2003, and that's the speaker enclosure. Each speaker carries 2 sides. That's item B. And the front of the speaker system is actually made out of plastic. So that's what we call the enclosure front, part 07036. And that plastic component is actually made of a resin mix that's supplied by a chemical plant that this company owns. So what I'm going to do is I'm going to place an order at the highest level for that speaker system, and we're going to show how Dynamics AX would handle the process in a mixed mode environment. So in this example, you can see that each of the components is made using a different, what we call supply policy, or manufacturing policy, if you will. So item A is assembled using Kanban moves or traditional lean manufacturing. Item B, the speaker sides are made using traditional bills of materials using production orders. And in some cases, we have to go out and buy packaging material. So we're going to see how the system would generate a purchase order to go out and procure that material. The front of the speaker system is made in a separate plant. So you're going to see that plant generate an intercompany demand order to build them those speaker fronts. And by the way, that plant is out of resin. So they're going to have to generate intercompany demand to their resin plant in order to supply them with enough resin so they can make those speaker fronts. So looks like a complex scenario, but essentially in Dynamics AX, it's a very simple process the way it works. So if you look at the infrastructure of this organization, at the very top, we have an OEM, original equipment manufacturer, and that's the company that's going to order those kits, the big screen TV, the speakers, the DVD player, the Xbox, and the main plant at one lower level is going to take the order, process the order, and generate the demand for all the components through the plastics plant and down even to the resins plant. And you can see the supply concept on the right-hand side. So this is what the organization looks like, and as you can see, the main plant uses bills of materials and Kanban moves to assemble the speakers. The plastic plant's going to use batch orders, and the resins plant's also going to use batch orders in order to make those components. So if you're digging into the Dynamics AX application, you'll see what we call a bill of materials or formula designer. Essentially what that is an ability to look at your bills or formulas in a graphical view and understand the makeup of the item, if you will. So if you can see this bill of material, it's got a traditional bill for part 2003, the speaker enclosure, and it's made up of the speaker front. That speaker front requires a resin mix, and when you see those items bolded in the designer, it means that you don't have stock for those items. So you can see we're out of resin mix and we don't have speaker front, so we have to make those, and we need to make speakers. And as you blow down through the additional explosion, you can see you need catalyst, you need resin beads down at the chemical plants. The enclosure sides are going to be transferred to the assembly area, and down at the lowest level you might have some free stock, which are the nuts and bolts, and the packaging material, which is needed to package up those speaker systems. So pretty traditional mixed mode environment. So what is different, what is unique about this ERP system? Well, most ERP systems, the traditional ones that have been around for 35 years, are bills of material based. Very few have the ability to run both bills and formulas. And formulas are important because they allow you to A, manage variability, but B, to produce what is known as an hourglass bill, an inverse bill, or a traditional A-frame bill. So if you look at A, in this example, the ability to produce a bulk item, consuming, in this case, as an example, might be bulk paint. D might be titanium dioxide that's consumed. So that's the raw material that's consumed to produce A. You can produce bulk by packaging it into multiple SKUs. So you can see you have examples of A1, A2, A3. That's quart cans, gallon cans, and 5-gallon pails. And as an aside, on the right-hand side, you can see from this process, the formula, we could actually produce co- and byproducts. So co-products might be this white latex paint with a mildewcide, might be a separate SKU. And a byproduct might be some wastewater that has to be managed and costed toward the end item production. So the process components are actually very, very different than a traditional bill. It gives you more flexibility and more robust functionality if you're running a pure process manufacturing environment. If you look at what happens when Dynamics AX does a mixed mode explosion, and when I say explosion, I don't say bill of materials explosion, because in this example we have a formula-based product embedded in a traditional bill of materials. You can see it as we work from the top down. It's generating a production order for the bill of materials assembly. It's producing planned Kanban moves. It's producing a batch production orders to produce those plastic chemical fronts. And it's also generating some procurement orders for corrugated box and packaging materials. So in this simple mixed mode explosion, you can see how the system is going down through the system and doing the products or sub-assemblies or components that are needed in order to make this the schedule. On the customer service side, this is an example of traditional available to promise or capable to promise if you wanted to include capacity. You can see the supply schedule. We start out with 100, a demand order for 100. The system is going to generate the supply order for the appropriate amount. It's going to consume that, 100, for this particular order, and it's going to leave you in the month of December with a net of 25. So you can see as the ATP screen is a forward-looking screen. It shows you all the demand generated on inventory, all the planned production orders, or if this were a pure item, purchase orders that would replenish the supply. So it's a forward-looking view for both raw materials and end items, and this is the impact of that demand and supply calculated. With Dynamics AX, when we begin to dig down into the production orders, we can see a bunch of the really kind of cool capabilities. In many industries, in this example, you need to tie labor resources to specific work centers. So think about having a skilled laborer who can program a CNC machine. The capacity of that CNC machine actually becomes the availability of that labor, the guy that knows how to run that machine. So in this example, we have some skilled labor that's going to assemble those speaker fronts, and we're saying to the system, I can't really issue a crew if I don't have the people with the right skills. And those skills inventories, things like certificates and verifications and training, come over from the Dynamics AX Human Resources package. This is extremely useful in those industries where you have to tie human resources to the work centers. So in the pharmaceutical environment, for instance, if you needed special skills to go out to the shop floor and calibrate instruments, they need to have special certificates. If you later add a plant maintenance application, when you're servicing certain machines, those people need to have certain skills and certificates as well. So this really shows the integration between the production side of the house and the human resources side of the house tied into the capacity constraints. And then obviously you can link the supply and demand requirements to standard warehouses and resources within the warehouses. So again, you could set up a warehouse as a functional resources. You could track things like floor space, or you could say if you had certain forklifts that were required to move certain pieces of equipment around. Again, the consumptions are tied to specific warehouses, specific plants, and this allows you to do multi-plant sourcing for both raw materials and for finished goods transfers. So what happens in this mixed mode bill of materials formula explosion? Well, the first thing you want to ask about is really about pegging. So what happens when one plant generates demand to another plant? Well, it's treated like a traditional internal buy and sell. So the paperwork is there. Plant A consumes from Plant B pays Plant A for that work and added process. But also when you peg down in production, either from top down or bottom up, you want to see what's known as interplant or intercompany demand. So this is not a traditional demand supply or safety stock replenishment. It's actually kind of like a sales order coming from the parent plant to the child plant. So in Dynamics AX, it's actually identified differently than traditional supply and demand. It's identified as interplant demand. So you can see that very clearly. And you can peg back to the original sales order from the lower level. So if I was in that plastics plant down at the lower level, I could peg back through the entire system and see that this demand for that speaker front was generated from this particular sales order, from this particular plant, and due on this particular date. And that's kind of important because when companies at the lower levels are producing products or inventory and they have capacity issues, they want to allocate their capacity to live production orders, and so pegging becomes important. If they were building these products for simply safety stock replenishment, they could deprioritize that safety stock replenishment and give capacity materials to an actual customer order to improve customer service. So that pegging becomes more important in allocating demand and supply. And you can see Dynamics AX has a variety of views and windows that lets you drill down on any line item, and then from that line item drill up to see demand and drill down to see supply. So anywhere in the system you can peg in both directions. And that's very important so that the operations folks know why they're building product and when. So at the upper level, remember we were using Kanban moves to assemble the speaker fronts. So this is an example of a scheduling board in Dynamics AX. It uses lean manufacturing principles. Everything's color-coded so that the workers don't have to drill down if they don't want to. And you can see each production batch is a different color, and as they move Kanbans from one supermarket to the production floor, they're simply dragging and dropping those colors into the appropriate day and time slot. So it's simply drag and drop and no data entry required to report on those Kanban moves. It's just like moving 3x5 cards from one to another, except you're using a mouse as opposed to dropping a card into a slot. And then from there, the system gives you real detailed visibility in terms of your Kanban board visibility, in terms of where you are on today's production schedule. As you can see, everything is very graphical so that the supervisors know where they stand in today's production. They see what products they're building, and they can drill down specifically and see what Kanban moves are scheduled for each product that they're moving. And another kind of cool component is up in the upper right, you see that red bar. That's the takt time. So the takt time determines the velocity of Kanban moves, and that's really based on customer demand. So if that customer were to call up and say, hey, by the way, I need 120 speakers, and I need it in the same amount of time, the supervisor could move that little lever to the right and improve or increase the speed of those Kanban moves, and so essentially increasing the takt time or the time between moves. If the demand was less, they could decrease the takt time and have those moves go from the marketplace to the work center a little slower. So this kind of gives you a visual clue as to how you're moving on a takt time and where you stand on those representative moves. So you can see kind of how that system worked. We had, this top-down demand from the OEM, which is at the highest level. The system took the order, generated an assembly order for item A, which was that speaker. It then put in a requirement for the variety of parts needed to assemble that speaker, and also at the same time in parallel realized that, hey, I need some packaging material. I'm out of packaging. That's the corrugated inserts and the boxes in order to ship that order of 100 speakers. So in conjunction to generating operational demand, it's going to generate demand for the packaging material. So it's also placing an order for the speaker fronts at the plastics plant. And that plastics plant is actually producing the enclosure front for that speaker. And so when they launched that production order, they realized, hey, by the way, we don't have enough resin to produce all the fronts that we need to produce for that speaker order. And so they generate demand to the lower level of the chemical plant, Contoso Chemicals, for a certain amount of resin, which will need to be produced and shipped up to the plastics plant so they can build those speaker fronts. So you see the whole system works as if it were one plant, even though they're using totally different scheduling, production, ordering, and manufacturing facilities. So that kind of wraps up my discussion on mixed mode manufacturing. I think the key message is today you might have an enterprise that runs either process, either discrete, either pure lean or project-based. But in the future, if your enterprise changes, you may have to go out and procure another ERP system that handles if you acquire a process manufacturing plant. With Dynamics AX, you don't have to worry about that. This is the last ERP system you're ever going to have to buy because it handles mixed mode manufacturing. So if you go out and procure a plant that's 100% project-based manufacturing, you can run it that way as well. So don't take our word for it. Read what the analysts say. You can see Dynamics AX is clearly, in terms of vision, the number one and pretty close into that winner's quadrant when it comes to execution on the Gartner Magic Quadrant. And these are really the A players when it comes to ERP systems. So you can kind of rest assured that Dynamics AX has been vetted by the analyst and given high marks for not only vision but execution. So at this point,
Bill, we have a question for you. Isn't IoT simply a connectivity story? Isn't it as simple as building integrations and making them available to the masses?
Well, integrations are definitely important, especially in the fact that we see organizations leveraging so many disparate systems. And it's simply not feasible to think that organizations always build upon a single unified platform that allows for complete integration throughout. You definitely need tools that allow for easy integration. But leveraging IoT is much, much more than just connectivity. Simply connecting things doesn't make them better. A la garbage in means garbage out. Manufacturers now aspire to really work more effectively and smarter. They not only need to collect data, but they need tools that can help them drive insight and real information out of all that data that they've collected. This is where Microsoft's Azure IoT suite really comes into play, with the ability to not only connect those devices, it can capture the diverse and massive amounts of data that's in play. It can integrate and orchestrate that flow of data back and forth between the sensors and the connectivity tools they're using, and then manage and analyze and present it as useful information to the people who need to make better decisions, as well as intelligently automate the operations where appropriate.
Thank you. Gil, will you talk to me more about formulas? Why and how are they different from BOMs, and why is it important?
Well, that's a good question. Unfortunately, it would take a long time to go through all the details, but I'll try to bring it down to a subset. First and foremost, for those companies that manage an inverse bill, that is, those companies that make multiple products from a single raw material, you need to be able to manage co- and byproducts. You need to be able to plan for them, you need to be able to schedule them, and you need to be able to cost them effectively. And a traditional bill of material is not designed to do that. Second, the management of material loss. So bills of materials, essentially, if you plan to produce 100, you have to make 100, and if you don't, if you make 99, then one has to be scrap. With formulas and batch production orders, material loss can occur in things like scrap, yes, but also waste, byproducts, yield by operation, and recurrence. So you can actually have byproducts. Let's say if I'm cutting up chocolate, I can reblend that as a recurrent product into the original process. So I think those are the two major ones, really, the ability to manage inverse BOMs and the ability to manage the multitude of material loss. The third big one is the ability to manage variability. So in bills of materials, you can't manage a lot of variabilities. Process companies need to have variability in raw material ingredient quality. So sugar content in orange juice or fat content in a hamburger, and formulas are ideally suited to manage that variability, unlike BOMs.
Thank you. Great answer. Bill, I see that you've highlighted some great scenarios about how the IoT story works for CRM. Do you see the same focus working on the ERP side of things?
Absolutely. A favorite one I like to point out is the Formula One racing team that we've partnered up with called Lotus F1. Lotus F1 builds and races their high-performance vehicles all over the world. On each of their vehicles, they have over 300 sensors collecting over 25 gigabytes in performance metrics for each individual racing session. During the season, they're constantly seeking to improve performance of their vehicles, whether it's aerodynamic designs or engine performance. But this means that they end up developing over 15,000 different production design plans for the cars during a single season. And from a production perspective, they build out all of their parts using carbon fiber and alloy metal 3D printers. In reality, they're more of an aerospace manufacturer than simply an automobile manufacturer. They're a rolling manufacturing facility that has an amazingly short production cycle. And on the back end of that production is Dynamics AX. They have needs to perform BOM maintenance, product design, configuration, scheduling, inventory control, execution, and costing, and all the standard items that a manufacturer needs. Basically, they simply have a much more expedited time frame where they literally have 24-hour turnarounds from product concept to actual product design and shipping out to the race sites. So as I said, ERP definitely has a play in IoT. It's simply an issue of being able to take all that data and then turning it into information that can be moved throughout the value chain, whether it's on the customer relationship side or on the back office side where it's needed most to make the best decisions for the company.
Thank you. That's nice to see the product in action. Gil, the final question. Can I run a project-based manufacturing plant in this mix? Can I use a work breakdown structure?
Yeah, that's a good question. Since today's event really focused on the three other ones, project manufacturers are very common in what we call the industrial equipment sector, and a project could run 1 month or it could run multiple years. If I'm building a space shuttle, if I'm building a big machine, it could take years and years, like an oil platform to build. So a work breakdown structure is really designed for companies that manufacture over longer periods of times, typically would have to manage against a specific dollar budget, so you can track the budget, and they may have incremental billing cycles built in the work breakdown structures. Typically when they have to manage many trades, so labor trades, when they have to manage a lot of different subcontractors is another reason to use a project-based system versus a bill of materials or a process manufacturing. So we actually have, tons of large manufacturing companies with deep work breakdown structures. Typically in a bill of materials, you might get a 7 to 10 level bill if you have a complex product. When you're building things like space shuttles or Caterpillar tractors or big tractors, you could have work breakdown structures that are 25 or 250 levels deep. And so that graphical project planning view is super key, and you can't really do that with the bill of material or a formula. You need a deep work breakdown structure, and that's a native part of Dynamics AX. Good question. I'm glad you brought it up so we could talk a little bit about projects.
Thank you so much. Thank you so much. And thank you, Bill Moffitt and Gil Garcia, for your time and insightful information. Guests listening to this webinar on demand, I'd like to encourage you to visit our website, www.dynamicscafe.com, to learn more about Dynamics Industry Insights. And you can also download our Lean Manufacturing ebook at aka.ms/manufacturing. Additionally, if direct person-to-person communication is your preference, please contact Craig Stephenson at cstephen@microsoft.com. We look forward to taking the next step with you.